All right, welcome everybody to the last of our webinars um, for this year. So we are very fortunate to have Marco Janssen from Arizona State University, who's going to be talking to us about his experiences in agent-based modeling simulation within the sustainability world. Okay, so without further ado, Marco, thank you very much for coming in today. I think just for the audience, they're not experts in all the domains. So could you just tell us about sustainability in an academic context? What does it mean to sustainability in what you do in your day-to-day work?
Yeah, sustainability is a kind of not a kind of specific discipline in a sense, although we now start having schools and or old schools of environmental science being kind of renamed into sustainability. So that's um, but uh, the kind of questions we do. So there are kind of different kind of dimensions. So we see a lot of kind of sustainability related programs come from an environmental science perspective. And our school where I'm at is more from a social science perspective, but most of the time we are focusing on issues which are very interdisciplinary and focusing on a lot related to climate change and biodiversity. So the kind of questions my colleagues are addressing are kind of thinking about future developments in various different domains about how to deal with trade-offs in decision making, what are the consequences of human activities on the environment, and yeah, it's very difficult to provide a narrow kind of as a very broad scope in a way what does not include in sustainability. And actually, I will be next week at the NASA headquarters to talk about sustainability at the moon. So also NASA has a sustainability program, although it might be a little bit different than if you're talking with people in conservation. But a lot of similarities are there. It's as a kind of key issue is a systems perspective. So thinking about a lot of the aspects that play a role. So that's probably why we see people who do modeling in a way in an environment like this, because we have a more kind of a systems perspective looking at problems, and we are very interdisciplinary. Um, Now we start seeing new faculty having a sustainability background, but typically we have people who have a background in all kind of different fields. But we are open to that. And probably what is different in a sustainability program compared to more disciplinary programs is that we are focused on application in a way. It's not that we are evaluated only on publications. Publications are important, but actually, I was 10 years in an anthropology environment before I moved to the School of Sustainability. And when I moved over, people say, you realize that now we will focus here on how to interact with the real world, not about publications. And so that's that's what we see in a typical sustainability program. So there is a lot of the students are also more kind of a lot of them are more activistic in that way. So although they typically complain about the faculty being too academic, uh, but yeah, that's the kind of it's a different nature. But the kind of problems that we address, we see a lot of overlap in terms of when you think about the use of agent-based modeling, a lot of overlap with other disciplines, but our kind of the way we operate may have a little bit more interdisciplinarity and more focused on practical applications.
Oh, thank you. No, that's great. Thank you for the introduction. So I think you've touched on it, but I just want to push a bit further. So can you just give the audience a bit of an untechnical introduction to the background of what you do as it relates to agent-based modeling specifically, right?
Yes. So my formal training is on operations research, and I started in the 90s in a group at the National Institute of Public Health and the Environment in the Netherlands. I was at a group where we developed the integrated assessment model for climate change. So some people may be familiar with integrated assessment models. Now it's more known as economic models, but at that time it was, well, there was more mixed between natural science models and economic models. So I was more in the natural science group. And I was applying optimization approaches to find the best solution. So for the climate change problem. So that's kind of interesting to sometimes to look back. And then I think it was something like 94, something like that, that Waldrop had a book about complexity and the Santa Fe Institute that I was reading, and I learned about genetic algorithms. And given my interest in optimization and the type of problems I was addressing, I got interested in that, but also start thinking about, well, we could think about this differently, because the natural science models, oriented models, they are providing scenarios in a way, given economic development and population levels, we get a certain amount of emissions, and that lead to a certain amount of climate change. And there was no response, in a way, from the social systems to what was happening. So they were kind of just an input that lead to a certain climate change development. And then the economic models, they assumed that the representative actor had a perfect knowledge for the next few hundred years to make their optimal trajectory. And I thought there could be something else. So I created in the mid-90s a model that, I called it, when I published it, I called it multi-agent systems, multi-agent simulation, where agents who had a certain idea about the problem, the climate change problem, and that defined their policy, but they also changed they could learn and change. And so there was more kind of what we now call an agent-based model. Our group also had interaction with the Brookings Institute, where Epstein and Rob Axtell were working on Sugarscape. So I met them too before the Sugarscape book came out. So that was also influential to see that there were other people thinking about those issues. And I had in my dissertation, I had a mixture of optimization kind of work, but then also kind of more simulation that we now call the agent-based modeling. So after my dissertation, which was kind of interesting, they did not want me to continue on agent-based modeling at that institute. People were not ready for that. And now I may get more into the integrated assessment community. At least I start getting more involved again. Now there is more interest in that, although also they have been doing a lot of the same for the last 20, 25 years. But there is now, of course, much more data available. And the technologies have improved. Myself, I went more to kind of smaller scale work and more in getting involved with the social science, worked more on social science issues, and did also a lot of work with psychologists, archaeologists. And so Yeah, so I've been involved in different fields in that way, using um, simulation. And I was 10 years in a anthropology school where I did a lot of work with archaeologists, a lot of human environmental simulations. Um, that's a lot of the kind of the background of the kind of agent-based modeling. And I also start teaching this I started teaching a course when I was still at Indiana University, early 2000. So yeah, that's in a way a whole interesting other aspect. Maybe we can come to that too at a certain point, about teaching this to different kind of disciplinary audiences. Yeah.
Oh, well, thank you. So you obviously had a long career and been involved in agent-based modeling almost from the start. I mean, well, not quite, but in the 90s when it really kicked off. So over the years, I mean, you're not the only one working in the ABM sustainability domain. Um, you know, can you just describe, because one of the reasons we're doing these seminars is we're trying to understand the broad church that is agent-based modeling simulation. And we're trying to understand who are the players, where is everything, how is it different across the different domains. So could you sort of like talk about sustainability within agent-based modeling? What are the groups? What are the differences? Or, that kind of thing, just to give us a flavor.
Yes. So this kind of question implies that there is also something like a church of sustainability. Um, and I think that although we now, since 2 years, we have a professional organization on sustainability science in the US, it's not something that is really organized. Sustainability as a field is not a coherent field in that way. So agent-based modeling and sustainability, when I was asked about it, I said, well, who are those? Because we typically we have people working on particular problems, and we may go to conferences on different fields, whether it is energy, or you may go to geography on land use change, or so there are different kind of domain areas. It's not that there is a specific kind of field of sustainability and agent-based modeling. So, but there are this within the sustainability area. There is a lot of interest in modeling. So actually, NSF has been for about 20 years doing this. They have changed the names. I think it's called DICES. They have these kind of programs of modeling humans and the environments, and there has always been a strong modeling component. So they want to have interdisciplinary programs. So that might be a good kind of example. And these are not just sustainability people, but there has been a long history of people developing models of humans and the environment. So there's been a lot of interest in that area. But typically, we see that people come from geography or particular fields that we don't have there's not a lot of people who have a background in different fields and then do modeling. So that's probably one of the challenges. And that's why you typically, when you do this work, you work in teams, and some people do the modeling, and they may have a particular disciplinary background. And that might not typically not computer science in a way. But and then there is collaboration with other people who may have less familiar with modeling, but they are working with modelers in a way. So I don't see this as a field, and yes. So So there are a number of journals related to environmental modeling and things like that. So those are journals where we publish our work, and they have a more natural science background, but they also now publish more publications where they also include more of the social sciences. So actually, probably a lot of the people who do this modeling have more an ecology or environmental science background and start to include more social science. And then they realize that they may not really have the social science expertise. And then they get people who have social science expertise involved.
So a lot of partnerships is what you're describing.
Yes. So this kind of work is, you do this in teams, and I know in some disciplines, and I've experienced that with some colleagues, when you're in a big project, they say, okay, I cannot be on a paper with so many authors because that really look bad for my tenure case. But yeah, in our field, we are used to be working in big interdisciplinary groups. Yeah.
Absolutely, yes. Yeah, I've definitely faced that problem myself. When you've got a big, especially in a large team. So moving slightly, shifting away from sort of like, just the sort of like domain and field. Sustainability could be argued as a controversial topic. Well, at least here in the US, right? And agent-based modeling. Oh, excuse me a second. Someone. Can we mute them? Okay, hold on. Where are they? Sorry about this. Martina, can you mute yourself? Because I'm trying to find you. Okay. All right. Can you hear me?
Yes.
Okay, excellent. All right. So, sustainability, controversial topic, like I say, released here in the US. And agent-based modeling simulation has always been a bit of a controversial application domain, especially within the traditional modeling and simulation community. Can you talk about those controversies? How do you navigate that? How do you deal with that in your work? Is there any sort of like pitfalls you've had to avoid, or things that you tend to be very cautious with?
Yeah, so I wonder, why do you say that sustainability is a controversial topic? I think it's in a way, how politics may use the term sustainability. So I think it's not controversial to think, how do we get a better future for our next generations? But then if political choices have to be made, that could be controversial. So models in that way could help with the decision making. So that's why modeling could be helpful. Actually, I find that there is not that much because we are a pretty young kind of field, and not as organized. So there are not these, as I have experienced when I worked in fields in economics and in anthropology, that there were kind of some expectations about certain methods that were used. When I was in an economics department, there was a lot of prompts that I used, simulation. So people and journals didn't want to publish my work in economics, but in sustainability, that's much more open. We are very diverse in methods. There is more probably a different angle about how to use models. There are a lot of agent-based models that are very theoretical, and I do also that kind of work. But a lot of the kind of the modeling that will be useful for sustainability field will be much more participatory in that way. And so you are working with people who may have no understanding of models and may not, and so there's a lot of kind of outreach needed. to realize how for people to see how models could be useful, that they are not we are not predicting the future. At least that's not what we will claim. And that a lot of the assumptions we make are the assumptions that of the understanding of people about how the world works. And so in that way, there's a lot of that we work with people who have no experience with also sometimes with quantitative methods that we work with. And so what are appropriate ways to include that knowledge? So I don't have in that way a controversy within the more academic area on the use of models. It's more that it can be a challenge to work with different stakeholder groups to have an effective use of models. And a lot when I teach agent-based model, I get a lot of students who have no kind of good training in programming or quantitative methods. So that can be a challenge too. So we don't have a clear pipeline about this is the method you use and it's the only method you can use. So there's a lot of diversity, but then there are the challenges about that not everybody might be familiar with. We don't have all common background. Yeah.
Thank you. Okay. All right. So that's good news. I believe everything you just said. That's great. So actually, that leads on to like my last question. So what do you see the future of sustainability and agent-based modeling? I mean, what do you see, I mean, the next, 5, 10, 15, whatever time frame you like? I mean, what is the Marco Janssen, like, your vision of that?
Well, yeah. Well, I certainly will not define this myself, but I think there are a number of interesting trends. So we start seeing we start seeing more interest in agent-based modeling also from the kind of traditional modeling fields in kind of sustainability related areas like integrated assessment modeling. So there was the Smith Foundation had recently a call for big projects for integrated assessment models for climate change, and they want to have novel approaches, and novel was in that way, agent-based modeling was considered to be highly novel because it's not very much used. A lot of proposals, I was a reviewer on some of the proposals. A lot of the proposals were still very traditional, but there were a lot of interesting new. There were a few agent-based modeling oriented proposals, and that's also what I hear from some other people in the field of integrated assessment modeling, which is a field that has a lot of impact in policy, that they now get more also asked about the use of agent-based modeling. But a lot of them have not the expertise because they were focused on the more traditional methods. So that's why I also have been approached again to get involved with this kind of work. So that's kind of promising to see that we can make a contribution to the kind of important modeling areas that has impact on the policy world. Another area which I think we will get, which I think is important, will be the more participatory modeling. Within sustainability, and I do a lot of work on governance. We know that if you want to have your work having acceptance related to any kind of interventions, you need to have the people involved from the start. So the whole participatory approaches in which modeling plays a role is, I think, is a field that will get more attention. It's also a field that I'm more kind of focused on. So, which is important. So we had a project on water governance in Mexico City with a lot of most of the group was actually in Mexico City itself, and they did a lot of the field work. I was kind of creating the model with a postdoc, and the model got used in the policy area. But initially, I had a model that was pretty kind of was not too complicated, but had a lot of kind of feedbacks that may lead to some sometimes surprising results. But when you work with stakeholders, it has to be much simpler. So because they wanted to be able to use the model on the spot with stakeholders, and you don't want to get some surprising results in that way. So and a key was that the stakeholders were accepted the model. So that's why there was so much attention to the data that was collected, so that the stakeholders accepted that, okay, this group has the right expertise and of this problem. I think there was maybe too much focus on the data. I'm trying to get involved now with some other projects on participatory modeling, and I would like to see this kind of speed up the process a little bit, that it's not first so many years of data collection, but key is the participatory approach. And that's might be maybe not that people are saying, well, this is new, but I see papers appearing about, we now have new biodiversity targets, and the only thing we need to do is to develop some models so that we can calculate what is the best thing to do. But that might not really work very well if you don't include the relevant stakeholders from the start. So the process of how you develop the models is important. And another area where we see actually a lot of work now is AI. Of course, I guess everyone is focusing on AI. I don't know in a way what will be coming out of that. We are testing in a way agent-based models with large language models. We are kind of we have changed kind of our perception about how useful this is. It's not, for us, it has not been very useful in terms of for models of the problems we are interested in. It's might be very interesting to see how those LLMs are trained. That's what we discover. But certainly there is a lot. There will be a lot of interesting new areas that we can explore, because we can now explore more data sources to extract relevant information on, say, governance, regulations, and other things that may inform our models. So the whole AI kind of revolution, that certainly will impact what we were gonna do, but it's really early days about to see how that will impact the field. Yeah.
Cool. Thank you. Thank you. So I have, and I have to say that the participatory modeling, that's that OR training coming through there. I can tell, getting the stakeholders involved from the start. So, all right. So I've been selfish. I've had my questions for the last 30 minutes. So now what we'd like to do is open it up to the audience. We do have quite a lot of participants here, so I would ask you just to raise your hand, just using the thing there. So, all right, we've already got one. So is it Madai? Did I pronounce it correct? Do you want to go first?
Maddie.
Maddie. Okay, Maddie, please
Thank you.
ask the question.
Yeah, sure. Thanks, Marco. Actually, I have a quick question regarding you're like that people are from different background in agent-based modeling. So, given that, for example, socio-environmental science, when we are working on socio-environmental models, we need to work with both social scientists and also biophysical modelers. And either of these fields has their own expectations. You know, for example, biophysical modelers they wanted to have really rigorous, for example, hydrological or environmental models. And social scientists really like to have to develop the model based on really rigorous psychological or social model. And we know that agent-based models are in between, you know. They are the one that should combine both these science in a way that first of all is practical, and and in addition to that, they should consider the model limitations. So how we could deal with these two different science when we are working in a, for example, socio-environmental modeling world? Thanks.
Yeah, that's a very good question, Madi. And yeah, this comes up a lot because we may have some specialists in different fields, and they all want to have all their details of their particular expertise in the model. So being trained in mathematics, I always try to keep it as simple as possible. So I get even more than also in some issues also. So yeah, this is a key challenge, and yeah, if for projects, it's really depends on how the kind of how the leaders of that project are kind of coping with that, or how successful they are. So I'm trying to being trained in kind of in mathematics and working in different fields. I'm focusing on trying to keep the simplest as simple as make these models as simple as possible. But certainly, I have experienced that in being in projects that some specialists wanted to have their component as detailed as possible, but then in a way we have to explain that. But if we want to have your hydrological model, if it include all the details, then basically the model will not be very useful for the integration and the modeling of the whole system, because everything will slow down. And why do we need to have all the details of that particular component? So there might be that there are different versions in a way. That will be one way. So there might be different versions of a model so that we can see also about what is actually needed to. But also, I think that one strategy that I've used in some projects is to make a very simple version, and then I ask the specialist, so okay, I get this with a very simple version of what I hear that you want to simulate. What needs to be added to this? And they often are surprised how it's very simple kind of processes. I can already simulate a lot of complexity, and then they realize, so they may not have to include all the details to be relevant. But that's the kind of the challenge that the specialists may not kind of they are often too in a box. They want to include all their knowledge, and for a modeling exercise that might not be needed. So it will be good in that way as a if somebody is the modeler on the team to show alternatives and to demonstrate that kind of simplified versions are effective. But yes, it can derail a project if somebody is hard-headed to want to have all their details included.
Absolutely, the curse of modeling and the yeah, there's always those special things that everybody wants to include them to wreck your
Yes.
model.
I have to say that I know, because I've done a lot of social science, and some people think that I'm a social scientist, which in a way I think I become. But that the more I know about the social science, the less I feel I can really model things in a very simple way, because I get to know too much in that way. So there is a trade-off of how much knowledge is kind of good for making kind of these integrated models. Yeah.
Thank you. Jacob, do you want to ask your question? You're up next.
Yeah, thank you. So I have a question about the participatory modeling and including stakeholders. I was at a talk recently where this person had done some modeling to optimize the bus schedule for two different cities because it was like for their school system, it was like a large part of the school budget was on buses. And so they had this whole process to optimize bus times to have fewer buses so that they could save money and then spend that money on other things.
Mm-hmm.
And they did this in two places, in Boston and San Francisco. And in Boston, they tried to make it sort of as participatory as possible. And they included all of the parents that they were able to give input. And basically what happened is they came up with something that would have been optimal at a system level. But then there were certain parents from the most economically advantaged neighborhoods that didn't like that their school time was changing, managed to basically kill the whole thing. And then in San Francisco, instead of fully opening it up, the participants were basically just the principals of the schools and the superintendent, and they didn't include all of the parents. And they had a whole process where, and the principals were really fighting for their schools, but then they would show them, okay, well, if we make your school this time, then look how that affects this whole other thing. And they were able to actually successfully do it. And so I'm curious if you've had any experiences like that, and if you have any insights around like who needs to be included in this type of participatory modeling, and who potentially should be excluded if you're really trying to get something done. And you might just lead to deadlock if you include everyone who conceivably could be impacted.
Yeah, so this relates to an issue that is not really related to modeling it in itself, but participatory processes. And actually, there is people start talking and also publishing about the green backlash in recent years. Well, we see that in the US, that a lot of the environmental regulations are kind of undone. And one reason is also that the people did not feel being part of when those regulations were created. So they said, well, these are not my regulations. So that's kind of demonstrated. It will be important to think about the consequence for all relevant actors. But you're right in terms of power differential, that there can be consequences of empowering people with knowledge, and that's in that way, that's not always that you participatory approaches, you may not get always what you may want in a way, and so yes, so I wonder what will happen in this Boston case, where if it was not participatory, because then what if the principals will push a particular new program, and will those kind of richer parents will they also speak up in a way? So how much is this the participatory process or the power differential between the stakeholders? That's not kind of clear. Participatory processes are very challenging and are interesting phrases, as you may. Because of inclusion, inclusion may lead to exclusion in a way if you don't include the right people, or you may exclude certain groups. The people who feel being excluded will not accept any of the outcomes. So it's very contextual, and who is moderating the process is very important. So I worked with NGOs. I do a lot of also behavioral games, and then I'm not the one who was doing the participatory process, and also with the Mexico City project, the person who was leading the participatory process was somebody who worked in the government, and he knew all the relevant stakeholders. So you need to have people who can communicate with the relevant stakeholders. Will certainly not be somebody like me who was too focused on the modeling aspects. And so you need to have some people who are professionally involved and are good moderators and understand these power differentials. So yeah, this participatory process is in a way the whole. It's not just we need to invite the people, and then we will as long as everybody is invited, this will go. And so you have to really to think about who is the right persons to moderate that process to be effective. And certainly a participatory process may not lead to the outcome you may want.
Right.
Yeah.
So true.
Thank you.
All right, thank you. So is there any other questions from our audience? I didn't see any hands up. Oh yeah, Sean, go for it.
Hi, Marco.
Hi.
What's the state of the art in teaching agent-based modeling to undergraduates these days?
That's I have not been teaching undergraduates in terms of the agent-based modeling myself. I did that for a while. So reason that I'm not teaching an undergraduate course on agent-based modeling is that the students who didn't came prepared. I didn't have a pipeline with the relevant expertise. So I wonder what kind of program that will be. I can imagine in a more quantitative program, a computer science program or a complexity program, you could teach it, and then you have to think about, what is the problem domain in a way. So because the textbooks that are out there are, say, ecology oriented or social science oriented or computer science oriented. So that what will be your focus? So I teach a graduate level course, and I have the students developing in the second half a project, and I have them first replicate an existing model, because they typically are too ambitious and they don't realize how complex models could be, and that you may not want to include all the complexity. So first have replicate a relevant model for that project, and then they can move from there. So for an undergraduate program, for an undergraduate course, I will have a more kind of defined set of projects where they will kind of tweak existing models. So I have not creating things from scratch, and I will do something like tournaments. But yeah, I'm using NetLogo for teaching, and that has been very well. But I think it's do you have a particular program in mind? Because it is very program specific. What kind of students you get?
Yeah, at Ohio State University, I think some on this call probably have heard about this, so I won't spend too much time on it. But we're developing a Bachelor's of Science in Computational Social Science, and ABM is certainly a big piece of that. I was just curious what
Yeah.
what your take on it was. But I like some of the ideas that you said. We're trying to backfill some of that
Yeah.
preparation that you talk about being missing. But
Yes.
we're trying to think also creatively about how we teach methods that that oftentimes require a lot of mathematical training, and that's hard for social scientists. And the counterpart to that is when you have well-trained mathematical students, they don't really have the social science background. So we're trying to rethink all of it see
Yeah.
how we can do it in a more kind of transdisciplinary fashion. So it was just an open-ended question for you.
Yeah.
I appreciate it.
So I developed a course for our sustainability program on computational reasoning. So computational reasoning is a quantitative reasoning is a kind of requirement now for students. So instead of statistics, in a way, what was kind of more a requirement, now it is quantitative reasoning. And there, it's the use of data and the use of models is kind of a key there. So there, this is a freshman course, and I have students also kind of using models and to make simulations and interpret the outcomes. And that's kind of, well, it's the first time that it's being taught now, and I'm not teaching it myself this semester, but it will be interesting to see kind of those kind of challenges are there for a lot of the undergrads. They often have difficulty in understanding where data come from or how to interpret data, working with data. So that's kind of those kind of skills will be also needed for probably in the kind of the backlog towards your agent-based modeling course. Yeah.
Great. Thank you very much.
Cool. Thank you. Midi, did I get that pronunciation right this time? Oh, you're muted, by the way.
Yes, I'm better. Hello, everybody. Hello, Marco.
Hello.
I think you remember me. We had this meeting in 2020. It's a long time ago.
Yeah.
And I was very interested by what we are saying about the sufficiency and the exhaustivity of the criteria to use when you make agent-based models, coming from a participatory process or not, or building your own model, your own agent-based model somewhere. And I was wondering, because we had this conversation 5 years ago, but we didn't pursue it, how to define the criteria on which you will base that you have enough dynamics or components. They are sufficient and they are for your model. You don't need more. How to define how to select the values, the dynamics, the criteria to put in your model, and how to eliminate others.
Yeah, I'm always saying to students that you never finish the model, but at a certain point you have to kind of there's no official endpoint in that way. So yeah, that's a very challenging question, because the different stakeholders can have. So I once had when I was in the 90s at an integrated assessment group of climate change, we had a very comprehensive natural science model. At that time, it took days to run one simulation. And so when we met with stakeholders, that was for the international kind of like now we had the COP30, but we were in the single digits at that time. When we met with negotiators of these international treaties, we demonstrated some of those results, and then if they came then with feedback and say, okay, in a few months we meet again, and then we can have a follow-up discussion. So in one afternoon, I one time made a very simple model that people could interactively with some sliders explore a model of very basic few equations, and the stakeholders loved that. Actually, they asked me to show this to all kind of policymakers around the world. So I almost had a year that I traveled the world with a very simple model. The focus was all about visualization. And because it was so simple and people understood what was behind it, they say, oh, but can you add now this? And can you add now that? So because they understood the model, they want to add more complexity. Before that, they had no idea what the model was doing. They just, okay, this is the outcome of this complex system. And then they couldn't really fully understand why the model was doing what it was doing. It was just a kind of a black box. So it is a very kind of iterative process. If you make the model simple and that people understand it, they will ask you to add some more complexity. If you add a lot of complexity, people may not understand it, and they may have some doubts about difficulty to understand the result. So in itself, this is a complex adaptive system of how people interact with your model. If you are in the participatory process. So I don't think there is a final stage of the model. And that's why we see with models that are used, we see that they may add more and more complexity when there is a long time interaction with policymakers, because they know what is in the model. They add more complexity because of what is needed. And then new things will appear, and then we say, okay, we can simplify some parts because they are less relevant anymore. So I think if you are with, I don't see there is a time where you say, okay, this is the final version of the model. If you are working kind of on particular problems like climate change and interact with stakeholders, this is a kind of continuous process. It may not be satisfying your question, but that's my experience.
Cool. Thank you.
Thank you very much.
Yeah.
All right, thank you. So, do we have any further questions from the audience? Anybody else? If not, this is actually, we're getting very close to time anyway. So I would like to say thank you, Dr. Janssen. I really appreciate your talk today. That's very insightful. It's very interesting to hear the similarities from your field to my own field, but also the differences as well. And hopefully that's what other people got out of this as well.